Hello, my name is Riccardo Scandariato. Welcome to the Advanced Software Architecture course. This lecture is Security Aware Design Part 2. In this second part, we cover the basic security mechanisms which provide the foundation to secure design. In the previous part, we have seen the security concerns of confidentiality, integrity, availability, and accountability, and we have provided some definitions and examples about them. So in order to build and design a system that is robust vis-a-vis security and is able to support these four concerns, a designer or an architect can resort to a number of basic security mechanisms like cryptography, authentication, authorization, auditing, and monitoring. In the next few slides, we will see these basic security mechanisms, which we will call building blocks for short, one by one and in more detail. One important thing to keep in mind already now is that often these mechanisms comes as off the shelf, and you as a designer are not supposed to implement them, but rather reuse sound implementations. Cryptography is a common technique that is used in security. For instance, it's often used in the context of confidentiality to hide the content of a communication. A typical example being the SSL or TLS protocols that are used by your web browser. But cryptography can also be used in the context of integrity. And often it's used to protect a message against alteration, or rather to make it possible to detect when a message has been changed, and also to avoid insertions or removal of additional messages in a sequence of messages. And finally, it can also be used for authenticity to prove the origin of the sender, for instance, via a mechanism called a digital signature. In any case, what is important to remember is also that when cryptography is used, we also have to pay attention to some other aspects, like, for instance, where the keys and the certificate have been stored, if they have been stored in a secure way, and how these cryptography material like key and certificates are distributed to all the parties that need to have access to them for secure communication. Authentication is one of the most important pillars of security, because without proper authentication, any other security measure is weaker, of course. Authentication refers to verifying a claim about the identity of someone, or also of a server and the computer, and so on and so forth. And these claims about identity are done via credentials. And there are several cases, and these can also be used in combination. Credentials can be about something that you are, like, for instance, a fingerprint or your iris. It could be something that you possess, that you have, like, for instance, a token, like a physical token that you use often to authenticate to your banking system, or something more simply, something that you know, like, for instance, a password. As before, because authentication is built on top of credentials, it is important from a design perspective to pay attention to where the credentials are stored and whether or not the storing is secure, and also in case of accounts, how they are managed, meaning created, renewed, and eventually cancelled or locked. Authorization is about checking the permissions, meaning who is authorized to do what, and these permissions often take the form of access control rules. Clearly, in order to have proper authorization, we need to have proper authentication first, because as I said before, we are checking who is allowed to do what. So it is important to be certain about the identity of, for instance, of users requesting certain access to certain resources. As mentioned in the previous two slides, the permissions are also a resource, and as a designer or as an architect, it's your responsibility to reason about issues like where these permissions are stored, and also the management of the life cycle of the permissions, like for instance updating the access control rules when an employee leaves the company, for instance, and so on and so forth. Audit trails refer to keeping track of the actions that are performed within the system, and also all the contextual information that is relevant to that action, like for instance who was performing the action at what time of the day, and so on and so forth. Audit trails can be used as a form of deterrent, like to try to avoid users to perform malicious actions, or also in a post-hoc way they can be used as a form of intelligence to understand how an attack had been mounted to a system. And this information, of course, is useful then to update the system to avoid future attacks. It's also, as an architect, you have to keep in mind that there are certain attention points when you're dealing with audit trails. Most importantly, as I mentioned before, you have to keep track of contextual information, and therefore it's important to know whether you are recording all the necessary information, and if you are observing also and intercepting all the actions of interest, and so on and so forth. The last of the building blocks is monitoring, which refers to mechanisms that you have in place in your system in order to observe the activity that is going on in a live way. Observations can take place at several levels of abstraction, ranging from the network flows up to the user activity. What is important is that we are using, with monitoring, we are using these observations to detect malicious behavior, and that can happen according to two models. The first is called misuse detection, where the system has a model of an attack, or rather a model of a behavior that is considered malicious, and the monitoring system is proactively looking for such behavior. At the opposite, we might have a model of what is a normal behavior for normal users, and we might be on the look for deviations. So, for instance, a user whose behavior is deviating from the model of normal behavior, and this is anomaly detection. As mentioned also previously, we have certain aspects related to monitoring from a design perspective, like for instance in a system, where do we locate the sensors in order to gather all the observations that we need, and several other aspects as mentioned on the slide. In these and the following slides, we will revisit the 4 security concerns of confidentiality, integrity, availability, and accountability, which you should know by now. We will look at the elements of an architectural design, like components, interfaces, connectors, and so on, and we will focus on how these need to be constrained in order to address each of the security concerns. And we will also, in doing so, refer to the security mechanisms, that is the building blocks that we have covered before. From an architectural perspective, preserving confidentiality requires that the architect identifies those components that are dealing with sensitive information. For instance, they handle or store sensitive information. And for components that are revealing or exchanging such sensitive information, the architect has to ensure that proper authorization is used so that sensitive information is revealed only to authorized parties, for instance, via the provided and the required interfaces. At the same time, whenever such sensitive information is exchanged across components, for instance, by means of connectors and links, there the architect has to ensure that proper encryption is used. And similarly, whenever sensitive information is stored, for instance, in a permanent way in a data storing component like a database, there also encryption need to be used. From a design perspective, preserving integrity means that the architect needs to identify the critical information in the system, meaning information whose integrity needs to be preserved, and then consequently also identify the components that are dealing with such information. And then for components that are, for instance, allowing the users to alter critical information, then proper authorization need to be put in place at those interfaces. Also, next to authorization, is also important to validate the parameters that the user is providing, for instance, to an interface operation when altering or modifying the critical information. Similarly, whenever data is permanently stored in a data storing component, it is important that such critical information is associated to a crypto hash so that modification of the information in the database, for instance, are noticed. And similarly, whenever such critical information is exchanged across components, for instance, via connectors and links, also crypto hashes to preserve integrity need to be used in association to the exchanged messages, and if necessary, also secure sequence numbers can be used. The design techniques to deal with availability in the context of security are very similar to those in the context of dependability. In particular, one known technique is to intercept and eventually filter service requests to, for instance, a server before they overwhelm the resource when the resource is getting overloaded, for instance, in presence of denial of service attack. And in order to do that, often black and white lists are used. That is, for instance, lists of IP addresses that are explicitly denied access. Those are the black lists, or that are explicitly allowed access. Those are the white lists. And of course, there must be also a way to scale resources and to balance the load. From an architectural perspective, preserving accountability implies that in your architecture, in your design, you have thought about what are the right places to intercept the calls and to log calls or invocations, and to log these into audit trails, and at the same time also designing the procedures and the mechanisms that will support the analysis of such traces, of such trails, in order to preventively or reactively discover attacks, and that is the forensics part. This is the end of the lecture on Security Aware Design Part 2. Thank you for watching.